Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nadira binti Azhar. My matrix number is CF230182. Today, I will go on to present about our project. This is our group member, which is me, Fahmin, Shazwan and Basit.
For general background for our project is there are 2 points. First is civil engineering overview. Civil engineering focus on designing, constructing and maintaining infrastructure like buildings, roads, bridge and like water systems. Civil engineering use physics, mathematics and materials science to ensure the safety, functionality and accessibility of this structure, contributing significantly to societal progress and quality of life. Second, Tacoma Narrow Bridge case study. The Tacoma Narrow Bridge, nicknamed Galloping Gertie, collapsed in 1940 due to aeroelastic flutter caused by wind-induced stress. This event marked a turning point in engineering, leading to advancement in aerodynamic and safety regulation for suspension bridge worldwide.
Hello, my name is Muhammad Shazwan bin Muhammad Nazri and my number matric is DF220020 and I will present about objective, problem statement and filler table. For the first objective is investigate and determine the amplitude of the Tacoma Narrow Bridge oscillation that led to its collapse. The second one is determine the amplitude of the external force and formulate the differential equation that explain the Tacoma Narrow Bridge collapse within the context of force oscillation. And the last one is to create our own, choose the topic that interests our group. Okay, for the problem statement, the Tacoma Narrow Bridge collapsed in the 1940s due to wind-induced oscillation. Strong and sustained wind caused the bridge to vibrate in a harmonic motion. The wind force matched the bridge's natural frequency, leading to resonance and amplification of vibration. This resonance increased the oscillation amplitude, stressing the bridge flexible deck. Eventually, this vibration exceeded the bridge structural limit, causing it to fail catastrophically. And the last one is lesson learned. Emphasize the need to account for external forces like wind in the bridge design to prevent similar failures.
Assalamualaikum, my name is Ahmad Fahmi. My matrix number is CF230058. I will present methodology for this project. Understanding the Tacoma Narrow Bridge collapse. The study investigates the 1940s collapse of Tacoma Narrow Bridge, focusing on the design, construction and environmental conditions. This historical analysis helps identify the factors that led to the failure, emphasizing the role of wind-induced force oscillation. Engineering methodology and application. The study used advanced engineering mathematics and data collection to analyze force, oscillation and resonance. This approach provides insight into structural vulnerabilities and guides the development of safer, more reliable bridge design for the future.
For the filler table, the number one is for fact from given trigger, force oscillation was the reason for the Tacoma Narrow Bridge collapse caused by the wind. For ideas, determine the Tacoma Narrow Bridge wind speed which contributed to its collapse. Learning issue, recognizing the significance of accounting for force oscillation that arise in Tacoma Narrow Bridge structural design. And action, determine the Tacoma Narrow Bridge amplitude issue and use a mathematical calculation to resolve it. Okay, the second is the Tacoma Narrow Bridge specifications range from flexible construction to force oscillation that which leads to collapse. Determine the external forces frequency and how it related to both an natural frequency and the force oscillation. Understanding how to use the force oscillation equation for engineering purposes. List out the necessary measurement of the previous collapse of the Tacoma Narrow Bridge. The third one is the collapse was caused in the part by the design phases consideration of aerodynamic force. Find and calculate the resonance due to von Karman vortex street using the second order differential equation. Understanding how to use the vortex shading and Karman vortex street using the second order differential equation. And the last one is determine all the details surrounding the Tacoma Narrow Bridge collapse and compute the result using the second order differential equation.
In this project, we use chapter 1 to solve the problem of this project. For non-homogeneous, we use case 3 as our solution because it is complex roots. Using non-homogeneous and variation of parameters, it appears an amplitude of 7 contributes to the stability of the bridge under the influence of higher velocity and speeds.
My name is Abdul Basit and my metric number CF230122. So in this project, we need to find problems related to civil engineering field by maybe in structure, hydraulic, environment, geotechnical or any related problems. So we decide to find problems in structure of bridge. So in 1940, there is one bridge known for its collapse. It called Tacoma Narrow Bridge. It failed due to resonance caused by wind. So in that problem, we going research deeply. We found that it failed because of the engineer not consider the force oscillation on his project. So the force oscillation is in structure analysis topic, in structure analysis course. So basically, what is force oscillation is how the magnitude and direction of force acting on a system change periodically. So we managed to understand the force oscillation, and we know this force oscillation are using differential equation because this is the basic engineering mathematics for structure analysis. So in topic 1 of civil of engineering mathematics is differential equation. So we managed to solve the calculation referring data on forum and website given, and we know that differential equation is really important in civil engineering field because this is a basic of engineering mathematics understanding. Without this understanding in differential equation, we as an engineer cannot manage the problems in sites.
For the conclusion, first is understanding force oscillations. Force oscillation occurs when external periodic force cause a system oscillate at frequency different from its natural frequency. Key factors include the frequency of the external force and its phase relationship with the system oscillation, influencing amplitude and behavior. Second, practical implication and application. Force oscillation are essential in various fields like engineering, physics and biomechanics. Recognizing their impact on system design and performance helps prevent potential damage and enhance the functionality of structure and machinery. Thank you.